Hey guys, it's Dave from 3DP and me. Welcome to my first ever live stream for the Millennium Mill build series. So, today we're going to go through my planned build for the Millennium Mill. The quirky bits about it, because it's going to be one of the dev team machines. And then we're going to do a bit of unboxing. I've got a number of supplier kits available and various bits and pieces that we're going to open up, check we've got the right parts, and generally get prepared for the main build. Right, so let's jump on over to Fusion first and talk through the build itself. So as you can see here, we've got a Milo 1.5, relatively close to what you'd expect to see for a BOM standard. There are, however, some differences. So having been hands-on with Jake's totally stock Milo, I have decided to go straight in with the full metal jacket mod. Fusion will not rotate. What is up, keyboard? There we go. As you can see, I've gone away with the printed side plates, and I've got these nice 6mm plates going all the way up. Now when we go through the actual parts, you'll see that I do actually have two variations of the FMJ plates, and the reason behind that is I'm going to be testing the lightweight metal jacket as well as the full metal jacket, and that essentially is a much lower cost option made from 3mm aluminium plate rather than 6mm steel. Next up, in terms of changes, you'll notice that I've got some slightly bigger motors than the stock, just because I was able to max out the capacity on the stock motors. So I've chosen to upsize those, and that has some knock-on effects on the control board choice, which you'll see when we get to that, when I go through the parts. Mostly the rest is near stock. I will be starting off without an enclosure. However, I do plan on putting all of my wiring in a separate container, just because this machine gets heavy and I don't want to be flipping it upside down to access it whilst I'm working on it from a development point of view. And I expect to have to test a number of different control boards, etc., as part of my role on the development team. And I just don't want to be turning this guy upside down every time I need to step a driver or anything like that. Alright, the last major change is I have chosen to go with a 2.2 kilowatt spindle, which a lot of people have done already, but I've gone for the square spindle route. And what this means is I'm going to get direct metal to metal bolting from the spindle onto the Z plate. This does, however, mean that I need a totally custom Z plate, which I will be machining on one of the CNCs at work, so I'm a little bit spoiled there. But if this works out well, then there's every possibility that Machine It Forward or one of our suppliers will consider adding capability to use a square spindle. I chose to go for 2.2 instead of 1.5 purely because it was the biggest, most powerful motor I could fit on this machine. Oh, speaking of size, one thing I did forget is that I've extended the Z clearance to 120mm, giving me much more height in the working volume. Now this wasn't possible based on Jake's testing on the printed variant, but we're pretty confident that with the steel plates on the side, that this should work just fine. Right, let's start with some parts then. So, right. Seeing as we've already spoken about it, let's start with the FMJ. So this here is one half of the full metal jacket mod. So I ordered these ones in custom cut, so each one of us in the dev team's actually got a set of these now. They were custom laser cut out of 6mm thick carbon steel, and just to protect it from rust, I have used some Hammerite spray paint. It's just standard black rust prevention spray. And all I really did was I cleaned them up with isopropyl alcohol, gave them a little sand where there was any blemishes, cleaned them again, and then sprayed. So, and they've come out lovely, nice shiny black to suit the extrusions. I'm very happy with these. They are quite hefty actually. I'm pretty confident that when we've got two of these here, we're going to drastically minimise the forward to backward flex, which was the major weak point that I experienced when running the all 3D printed variant. Yeah, so super stoked about these. They've turned out great. Obviously I've not fit them yet, but as far as I can tell they're nice and flat, and everything looks nice and lined up, so I'm very happy with how these have turned out. Heavy, as you can see. Right. Hey, nice to see you, Jake. Did the bed liner turn out nice and smooth? I could only find textured versions, and I wanted that smooth fit for clean bolting onto the frame. Right, so up next, this is what I'd call a bit of an experiment. So one of our users, who happens to live just around the corner from where I do, in sunny Sheffield, chopped these out of some 3mm aluminium for me, and now, whilst these in no way feel anywhere near as robust as the 6mm steel, they could be manufactured for significantly cheaper. So I'd be very interested, and will be testing at some point, what the difference in performance is between the 3mm aluminium light metal jacket mod versus the 6mm steel. If nothing else, it's certainly a lot lighter and easier to handle, and you obviously don't have to spray aluminium because it won't rust. Yeah, so very interested to see this. Not looking forward to undoing all these bolts multiple times to swap back and forwards to test it, but some sacrifices have to be made. I reckon we can get these out for about 10 to 15 per set pounds, which is obviously a lot cheaper than this set, which is about 55 per set, plus the cost of the spray paint, which was an additional 10 to 15 depending on your source. So obviously a bit of a cheaper option. What have we going on here? Textured version. I've only sprayed the outward faces. Gonna blue the mating faces and keep it well oiled. Fair play. I looked into the cold bluing, and the cost of getting enough cold blue material to do the full thing, well, kind of put me off of it, and I opted just to go for the spray painting route, which I'm hoping will be sufficient. Otherwise, I would be seriously tempted to go for stainless. I reckon if we can get a decent bulk order in of sort of 20 to 50 sets, you could get stainless prices down to an acceptable purchase point, and then again we wouldn't have to worry about rusting and so on. So let's pop these over here out the way. They are heavy, those. Right, so extrusions. So here in the UK we don't currently have any so here in the UK we don't currently have any suppliers for the frame kits, which is a bit of a shame. Obviously if you're in the US, you've got Fabrico and Deep Fried Hero, who both do fantastic frame kits, but unfortunately the shipping makes it not so economical when you're purchasing it over here. That said, we are blessed with Ooze Nest, who are pretty much the exclusive seller of open builds type extrusions here in the UK. That said, the cost of just putting your frame into their system and buying them one extrusion at a time cut to length actually comes out not far off a frame kit price, so all in, cost wise it wasn't too bad. Open these up, be careful not to scratch it. Oh, I think I've left my yes I have. So we won't be measuring the length of these today. I have left the tape measure downstairs from when I was fitting a radiator earlier. But I did do a quick check of them when they arrived, that the overall lengths seemed about right, so we'll just have to hope. Right, there we go. Oh, very neatly packaged, the two-face ones tucked inside the C-beams. So yeah, they look nice. Nice neatly cut edges, which is good to see, because often when you order these from some of the Chinese suppliers, these come with a lot of burrs that you need to clean up on the end there. They look pretty neat. Before I build it, I will test how square the ends of each of these are. But first glance, it's all looking quite nice. Just to compare the colour, let's see how we look sort of side by side. Oh yeah, that's gonna look the part. Yeah, nice. It always blows my mind with these 2020 extrusions how small they feel until you assemble them into a frame. Again, neat ends, all looking pretty good. There's quite a few boxes of these. I'm just going to check each of them. But yeah, pretty excited to get the build started. The one thing that I know I am waiting on is 3D printed parts. Unfortunately, this beast next to me, my VCore 3, is out of action right now. But the man himself, Jake, is sorting me out with a full set of parts. So I believe he shipped them the other day, so they should be here soon. So hopefully we can get the actual build series started in the next week or two, which will be exciting. Yeah, looking good. No, that's just dust. So one thing you'll probably notice, everything in my house at the moment is dusted. Literally everything. I'm in the middle of a renovation, and if any of you have had any rooms in your house plastered before, you'll be aware of how much dust it creates. And it gets everywhere, literally, inside the packaging and everything. Oh, it's impossible to handle. Yeah, and so if you imagine having one room plastered, we're having the entire house plastered a room at a time. So pretty much every time the dust is fully settled, we get the next one done and we're back to square one. Again, these are looking nice and neat, cut at the ends. Just dusty, just need a good wipe. Jake, when are you planning on swapping the FMJ plates onto your build? Now that you've sprayed them and all? Right, just 2 more little packs of these, just to check. So far they're all looking good. Like I said, some of these are longer than the stock length, and that is to support the higher clearance build that I've chosen to go with. Quite possibly these parts here for the Z, but we will see. Little guy. I've been working with 40/40 based extrusions at work recently, and it just makes these little guys look so cute and tiny. Unfortunately, the other sizes of these extrusions typically don't come in the C-beam format, which makes it so easy to incorporate the lead screws into your frames and so on. You see that? Literally the dust flicking off of that packaging as I opened it. Nice. Awesome. So that is my frame. I've just quickly been checking all of the ends are nice and neat. As I said, I've left my tape measure downstairs. Unfortunately, I won't be measuring it today. 2 weeks off in Feb with no plans to do anything. It's probably then. Awesome. So you'll probably have them on before I get this up and running fully, but I can't wait to see them in action. It's honestly, having tested your build out, the weakest part was the forward-backwards tilting, which was almost entirely flex in those 3D printed brackets at the bottom. So yeah, it's going to be quite a significant improvement, I think. Right, I'm just going to empty this box so that I can fit the extrusions in it. Out of the way. Wonderful. Is anyone else that's viewing partway through a build or thinking about starting a build? Just let me know in chat. It'd be good to know what your plans you guys have got. Are you going all stock or are you mixing it up like everyone else seems to be from the start? Right. Let's get to more interesting things. So, as I said in the opening, I've been hands-on with the 1.5 kilowatt spindle, and I didn't actually max it out. The flex and the printed parts in the Z-column was the limiting factor at that point in time. But because I knew I was going to be going full metal jacket, I did go a little bit over the top on the spindle. Mine is from Vevor, which you can order off AliExpress, and I've included the link in the description. Or in my case, I actually bought it direct because they have a site in the UK, and you can, that way you don't have to pay postage. So do check if they've got a local website. If you're buying from them, you save quite a lot. I think it's about 60 quid postage you can save. Mine has come with some nice big wrenches to do the collet and the tightening it up. I'll just get rid of that paint. Right, just some instructions. Yep, how to wire it. pretty straightforward, only like 4 connections. Right. Okay. Oh, so it's nicely packaged in there. Lots of polystyrene keeping it safe. Yes. So the one downside of this order, I'm based in the UK, but I've got imperial sized collets. Devil's work. I will be ordering some metric collets. Can't be dealing with imperial sized parts. My brain can't hack 25.4 times whatever number I actually want. Good to have though, just as backup in case you need them. So yeah, so here is the 2.2 kilowatt square spindle. It's a bit of a big boy. It's an ER20 collet, which means we can go up to bigger tool bit sizes. However, realistically, with a spindle like this, we probably aren't going to be using anywhere near the maximum diameter that one of these ER20 collets can hold. But I'll be very interested to see how much we can get away with running at lower RPMs with this, just because it will hold its torque. I have a bit more torque at lower RPMs than the smaller models. It is air cooled though, so I have to be a bit careful with how low I can really try and go. I have been looking and potentially found a 6,000 RPM spindle. I'm working with a supplier at the moment to see if I can get hold of one. They're about double the price of these ones, but it would be perfect if I could get it to work. So like I said, the main reason I went for this bad boy is these mounting flanges, so direct mount onto my Z plate, so there should be absolutely no flex from a 3D printed part in there, and just generally the process of attaching it and aligning it should be a little bit simpler, just because you're not having to tweak the whole printed part alignment as well as the spindle inside that printed part. It's just the one part that you need to deal with, and then an aesthetic cover that just goes over the top after you've finished doing all of that. Just quickly show you that in Fusion. So as you can see here, there is the square spindle mounted, and then we've just got this little printed cover with the Millennium Mill logo embedded in there, and some internal wiring for the wires to feed down the side to your cable chain. And that casing is purely cosmetic. It doesn't really do anything else. Well, it holds the cable chain. Other than that, it's cosmetic. So what that means is I can get away with some fun ideas I've got for GoPro mounts, spindle lighting, and fun things like that. Also, it's easy to replace because it's literally just 2 bolts to get it on and off. Right. What I will also be playing with is this little front cover here. Basically, can just be undone and replaced. It's literally just a plastic cover. So what I might try and do, once I've got everything up and running well, is design a more slimline variant of this, or even fully incorporate it into the housing that I just showed. Right, hi Andrea, nice to see you. Yeah, get on board. So Millennium Mill is a perfect first CNC project if that's what you're looking for. I was very much like you about a year ago when I was looking to branch out from just the 3D printing that I normally do. Came across this project and had quite a lot of chats with Jake. I was just about to buy a house and so on, so I wasn't in the position to actually get one built. He was kind enough to lend me his for a few months, and honestly, it's a wonderful machine to get started in down your journey in the CNC. So it's good to have you on and listening. Yeah, so 2.2 kilowatt spindle. Bad boy. pretty standard VFD that came with it. Nothing that interesting. Oh, hi Samuel. Hey, Techmorphic. I'm loving your build. I'm definitely very jealous that you're up and running and going so well already. I feel like I'm miles behind. So, just a small VFD size to go with the spindle. I think it's slightly over spec'd versus the 2.2 kilowatts. Oh no, exactly. Spec to match, 2.2 kilowatts to go with the spindle. Just gonna have a little look inside and see what we got here. These VFDs bought from China never have quite the same feel, robust feel as the spindles actually do. But it looks alright. Again, it's Vevel, bought at the same time to match. It was unclear from the datasheet whether or not I was going to have to use an analog, digital to analog converter to convert a PWM signal to a true analog. But we'll find out for spindle speed control. If it comes to that, I'll just have to order the little board. I know that Jake used that exact route, so we know it's possible, we know it works, so I'm just going to pop this little bad boy back away and we can move on. Right. Sorry puppy, just taking up the dog's little bed. As you can see, she makes herself right at home on the sofa. An absolute princess. She has to sit up the highest level of soft cushioning that she can. Right, spindle done. Good go. Right, now things... no, not that interesting. So here we go. I will be going for I'm trying to test out a Linux CNC build. So to do that, I've got a Raspberry Pi 4 here. I've also started testing this on a Raspberry Pi 3B. Unfortunately, that board is not officially supported by Linux CNC, so there's a number of sort of steps you need to do to get the image to work. I was going to go ahead and just do that way, and it was looking like it was working fine. I've got it actually up and running on another Raspberry Pi, and I've posted some pictures of that in the Discord already. But then I thought if people are following this build along, it would probably be best to try and do Linux CNC the right way. So using their official build image for the Raspberry Pi and going that route. So I have gone and got myself a Raspberry Pi 4. It took me a while to find somewhere that was in stock. It's the 4GB RAM version. You don't really need any more than that. Also, I just couldn't find any of the 8GB ones. I also couldn't find it on its own, so I've got all the random crap that comes with a starter set with it. But it was still cheaper than buying one of the scalping priced versions. Plus the case might be handy for the build, just to keep things neat and tidy inside, but I think realistically I'll have it exposed, I'll have a heatsink on it, and I'll have a bit of cooling air, making sure that I can get the most performance out of that and my printer control board as possible. Goodbye. Okay, right. So, seeing as we're on control boards and stuff anyway, let's talk actual control boards. So, I've decided to go with the FiSec Spider King. A few reasons for that. One is the chip that it uses is one of the supported ones for an add-on module for Linux CNC called Remora. And that add-on allows you to offload the low-level, time-critical, hardware controls, like the step and direction signals, to a microcontroller rather than doing it direct from the PC, like you would using like a Mesa card or something like that. So that's the reason why I chose the Spider King. The second reason is that the board already has a Remora config written for it. It is in beta, but the chip itself is already fully supported, so a config file is reasonably easy for us to work on from a dev point of view. Lastly, I've got my backup. So if all goes to pot, I can swap to RepRap firmware. So very happy with this so far. Comes in a fancy looking box that actually isn't that robust. As you can see, the side fell off of mine. And again, we have the dust coated board because I happen to have it out on the desk for one whole day. Disgusting. So this board is drastically overkill for what we actually need. But if it works out really well, what I'm going to do is try and work with FISEC to get a 4-driver board with just the 4 high current drives. Chatting to their engineer, they're already interested. They just want to reduce the risks, so they want to have everything working and proven before they put any design effort into that. But they seemed pretty keen on exploring options for this. So what this board actually has is 4 high current drives, so these can actually drive up to 6 amps, and then 6 low current or normal 3D printer, so your normal for 3D printer stepper drivers will fit into these ones. As you can see, they've had to change the connectors from the JST style to these larger ones, just because these connectors aren't rated for up to 6 amps, so you'd end up melting them. We've then got a whole host of inputs and outputs from a power point of view. Yeah, you got heated bed, 5 extruder outputs, and yeah, so lots of options in terms of I/O. So basically, I should never run out on my build with this. It came with all of the little connectors and thingies that you need. So here you are, you got your little screw terminals that plug in here for your high current motors. We then have a little pack of some standoffs. So interesting part with these are they've actually given us the hardware right now, and the board has some mounting holes for it, for you to put a 120mm fan with these standoffs directly mounted above all of your stepper drivers. So they've put a good bit of thought into the cooling of the drivers on this, so I'm actually very confident that we should get some really good current and really good power output from these for the steppers. Hence why I was confident to go for the larger stepper motors, and I should be able to run them at their maximum rated current. I shouldn't have to drop it down. It also came with this little Wi-Fi module. So this is if you're using RepRap firmware. There's a little section here where you can just plug that directly in to give you Wi-Fi. And the last thing that's worth noting is the actual controller for this board is hot swappable, so you can actually swap or change the controller. It's a bit of a gimmick, I think, really, that the only reason I can see doing that is if you've blown this up somehow. But in reality, normally you damage other parts of the board when you do that, so I don't think I'm likely to ever change that. But I think it's good for them, because if they've got a chip shortage, they can just swap this little module with whatever's available rather than the entire board. So that's what I'm going for. Just get these back in this little package. It also came with a USB charging wire, which I stole because I needed that wire for something else I was doing at the time, and haven't put back in here. Just a USB-C to regular USB. here are the drivers that go with it, so the big 5160s. So the chip is actually the same chip that you see, the TMC 5160, that are in lots of the high voltage 3D printer drivers. But the PCB layout and the MOSFETs and other components on the board have been uprated to handle, I think it's up to 50 volts, so, or 55 volts, basically some overhead to cover your 48 volt power supplies. Might even be 60, oh 55, there it is, 55 volts. 6 amps max, and then they come with this chunky heatsink to go across the top there, so they're going to a bit of a beast compared to your standard driver. And obviously Visect have actually sent me this board. They've sent me 4 of them, so I have got a spare, so it's screaming 4th axis at me. It's going to happen at some point, but it's a little bit away yet. I'll just get the basics working first. Right. What have we got next? Okay, so next up's pretty boring. So, fasteners. I highly recommend you buy a fastener kit. Loading all of these manually into a bolt supplier is a pain in the arse. And it is almost always more expensive than buying the fastener kit. Fabrico do one if you're in the US. Visect, and I've put a link in the description, have just released a fastener kit. I've not tested it myself, but I did go through the pictures of the BOM that they've laid out, and all the components look correct. The heatset inserts look like the right style, the bolts all match the descriptions, so long as the kit arrives as per the description on their website, it should be good to go, and cost a lot less than ordering it this way. I think about half the price than ordering direct from Accu here in the UK, and they're one of the cheaper suppliers for buying bolts in this way. Yeah, definitely wish that kit had been available before I ordered these. It would have saved me a lot of time and effort and money. And that said, Visect do Voron fastener kits. I've used them before on a Voron Zero, and they were perfectly fine, so I'm pretty confident that as long as they've got their BOM right, that kit will be good. Right. So, just some additional inserts. For the ones where I didn't need many of some of the random sizes that I don't standard stock, I just bought this little mixed kit, just for convenience. It was about the same price as trying to get individual ones. And then thread locker, you're going to need some of this bad boy, because the vibrations when Milo's cutting will get those bolts loose if you don't use it. Very important on your linear rails and sections like that. Right, power supply. So, because I'm running slightly bigger motors, I've gone for a slightly larger power supply. Although mostly I'm using this one because I had it left over from another project. This is a 24 volt, 350 watt supply. Should be more than enough for the motors. I would like to upgrade to 48 volts at some point, but, well, maybe I will before I start the build. I haven't decided yet. We'll see. So that should help with maxing out the speed and the material removal rate, just because if you go for higher voltage, your steppers have maintained that maximum torque that they can be used at for much longer than at the lower voltage where it drops off quite fast. But it does mean that your total power wattage needs to go up by quite a lot, and your power supply cost goes up quite a lot, quite quickly when you do that. Okay, so here's an interesting one. Sorry, Jake. I must have forgotten that one. All of the 5-sect gear that came with this so far, they have sent basically for free to support us for now. And I asked them some questions initially about whether or not they had considered Linux CNC support on their boards. And basically they hadn't had enough people ask for it yet compared to the sort of 3D printer demands. But the engineer seemed very open to doing it. It would be really sick if we could get a Linux CNC setup with a custom board that they supply, but you know, I think we need to prove the Linux CNC route before we do that. And I think we should probably opt to maintain it such that that board also still works with RepRap firmware, because then it gives our users the choice. That would be really cool. Yeah, I will put you sorry Jake, I will put you actually in contact with them if you want, when we next have that chat. But they're basically waiting on me to feedback my experience on setting it up on that board. Right, so here we have the CNA motion kit. So the link for this is in the description as well. I chose to pay a little bit extra for the blackened rails, so they got a little bit of the blued, it's called bluing even though they're black, anti-rust protection on there. This motion kit comes ready and pre-assembled, so each of the rails already has the 2 carriages required installed, and the real benefit for this is that those carriages are matched to the rails. I think I already opened one of these. Need to be a bit careful because they have some packing grease in there, as is normal for these rails. No, I've not opened any of them. This kit includes everything from the motion section of the BOM. So we've got your bearing stack there. They feel pretty smooth. They look as expected, to be fair. Again, what we really need to check on these is just to check that the OD and IDs are to spec, because that's the most common flaw that you get with cheap versions of these bearings. That said, CNA rails, I've used them for the rails on my 3D printers for years, and they've always been great. So the only difference here is this is the first time I've got the blued rails, so that will be interesting to see how well that coating lasts and whether or not it wears. Got all the lead screw nuts, just brass ones. Doesn't come with any spares, this kit, but you know, as long as you don't lose them, you should be okay. They have replaced things in the past when they've had delivery damage for me, so generally speaking I think they're pretty good in terms of a supplier. We've got three lead screws here. I'm just going to roll it along the table and just get a feel. My table's not the flattest, but yeah, so they look nice and straight. There's no obvious bend. Obviously I'm not using a calibrated granite table here, but I've received ones in the past where that wobble was very obvious. So no, they're all looking nice. Yep, so we've got the little belt kit, the pulleys for the Z axis, and the little closed loop belt, which looks good. 200, I think that's the correct length, isn't it? Let's just check the BOM. Oh god, can't scroll. So motion, yeah, 200 mil. That's what I thought. Yeah, so that all looks good. Oh, I've got little greasy fingers now, struggling to to function. So looking at close on these, the profile on the teeth looks nice and clean. You never can really tell what to expect with these if you're going to get a proper GT2 profile, or if it's going to be one of the fake ones that's not bad, but it looks pretty good. Anyway, so proof will be in the pudding. Yeah, it's looks nice. I feel it's nice and smooth. There's no big burrs on them, so generally they look quite nicely manufactured. Right, what have we got next? So we've got some flanged bearings here. Again, let's just have a little feel of them. The proof again will be in the OD of this outer race in terms of fit, but they run nice and smooth. Such a standard part. Again, I'm not too worried about these. Now these. So these are the only part that I know are not to the BOM spec. The OD is smaller on these locking collets than the spec ones. Yes, so the CNA kit, there's two options there. You can pick just the rails and carriages, or you can pick the full motion kit, which includes everything I'm opening now. It's the same link for both down in the description. This is the full motion kit I've got here, plus the upgraded black rails. I don't know if you might have to message that and put it in the comments for the black rails. I can't remember whether or not they set that up as an option yet or not. Anyway, so yeah, these are the only thing that I know that isn't to the BOM. They didn't have a larger OD. I checked through the design, and as far as I'm concerned, these should work exactly the same as the ones with the larger OD. If I have any problems with it, I'll have to feed it back to them. It certainly won't change anything you need to print, etc. It will just be a case of whether or not they're strong enough. But at the end of the day, they should be. They're both sides are just held on with grubbed screws, so I'm pretty confident that these will work as expected. Right, throwing things everywhere. So we got some some little whatchamacallits, lead screw nuts. Not nuts. God, why am I blanking? Completely blanking what these things are called. Someone help me. What are they called? Spider coupler. Thank you. No idea why that went out of my head. So these are just size to go from your motors to the lead screws. So that tolerance on that side looks about what I'm used to. Lead screws slide on fine without too much force, but there's not much wiggle there, so once you clamp that down, it's nice and tight. And obviously the other side for your motors. Thanks, Leandro. Leandro? Yeah. Had a total mind blank there. So these look quite good. Visually they look pretty concentric. Again, this is one of those things where once you put it on, you'll know immediately once you start spinning your motor if you've got a problem. But visually they look fine. That's my bag. Right, I'm gonna quickly grab some tissue just in preempting, so I'm going to open one of these rails and just check the carriages run smooth. But I want to just have something to wipe some of that oil down quickly, so I'll be back in 1 second. Right. So we're out of kitchen roll, but I have found some toilet paper, which I'll have to do. Right. let's just pick one of the long rails, seeing as it's closest to me. Let's have a look. Just a little bit of a wipe down. So obviously this grease that's on there at the moment is your protective grease for transit. You can't use that same grease as the final lubricant, so do make sure you buy yourself some white lithium grease. You get some of the spray stuff, which is okay. I prefer to, this is good for just topping stuff up, but I do prefer to use, I've got some of the actual, the actual grease, thick grease in a tub that I use for my 3D printer rails. What I'll do is when I do a proper maintenance, I'll inject some of that into the actual carriages themselves. And these ones are quite good actually. They appear to come with the grease port actually open and present, so that means it's much easier to inject the grease into it. You get what I do is I order a little syringe, you can get them off Amazon, with a small, I think it's about a 2 diameter, about 2 mil diameter syringe needle on the end, and then you just put the grease in there and then squeeze that into the port, and that lubes the inside from the inside out. And that makes the maintenance a lot easier than some of the cheaper rails that don't have any access into that. So when I spec'd and was speaking to CNA about this kit, I told them to go for a medium preload, because we don't have the mass really for rails this size to preload it just with the weight of the component itself. And now what that means is when you turn your rail like this, you might think, oh no, my rails aren't super smooth, they don't just drop. But actually that's because of the preload. What you really want to look is when you actually push them, like, do they roll smoothly, which this one is, and almost more important, is there any play in it? And now I can't actually get any wiggle in these at all by hand on either of these two cartridges. Both of them roll nice and smooth. So this rail as a whole is looking, well, it's looking very good actually. I'm very impressed. What is a little bit annoying is the end of the rail. So the rest of it has been nicely blued, nice black look, but the end is just an exposed cut, which is a little bit of a shame. Like, it's just a small touch that, if you were being pedantic, you'd quite like that end to be blued as well. But it's really not the end of the world. It's a very minor thing. Yeah, pretty happy with those. Obviously I will not waste your time after I check all 6 of them, but if they're all like this, then very happy with the kit if that's the case. Again, thank you to CNA. They sent these at a reduced cost, not for free, but we appreciate them adding another supplier or option to our list, which is particularly useful for those of us that aren't in the US, where our small fat manufacturers are. So big shout out to Fabrico and Deep White Hero and any of the other small suppliers that are out there. Please do support them directly if you can. If I was in the US, I would have bought a lot of my stuff from them, but it's just not practical over in the UK to purchase from them, unfortunately. Hopefully we'll get some UK vendors on board, but there doesn't seem to be quite a bigger community of little vendors like that available, unfortunately. Right, just try and wash some of that grease off my hands. So that's the motion kit. Yeah, pretty happy with that. Just gonna roll this all back up. It came just in the bubble wrap and in this sort of double layer thickness cardboard box. so it's pretty well protected from bending and stuff during shipping, which is always a risk with the lead screws and rails coming from China. Let's get that back in. Right. Cool, we've made good progress. So, not the most exciting things next. So we've got some e-stops. These are just off Amazon. I actually ordered 2. So I plan on enclosing my machine pretty soon after building it. And I will be wiring one of these on Milo itself and one of them on the enclosure, so that when the enclosure is shut, I've got an e-stop available. When the door's open and I'm clearing up chips or, you know, generally debugging it, I've got one that's immediately next to me where I'm working. As an engineer who works his day job and sort of specs some of these safety systems, I know the accidents that can happen if you don't have quick access to an e-stop. If you're putting an enclosure on it, I highly recommend you make sure there's an e-stop available for you to easily touch within reach without any doors or anything in the way, in every setup that you can envisage you using the machine. So if you're stood outside the enclosure with the door shut, you want to be able to hit that e-stop without having to open the door and get to Milo. Equally, if that door's open and it blocks direct access to that e-stop on your enclosure, you want to have one that's available maybe on Milo or on the other side of the enclosure that you can easily hit really quickly if you're in there like clearing out chips or something whilst it's running, because that milliseconds do make a difference between smashing an end mill or chopping your finger, etc. So safety first, guys. It is a serious machine at the end of the day. Yeah, another boring one, just a switch. What I do recommend is, especially if you're using the bigger spindles, don't cheap out on one of these. Buy them from a known supplier. Don't get it from AliExpress or eBay. Get it from RS or Parnell or somewhere that you trust that this is a properly rated connector, because I've seen loads of these melted on 3D printers and stuff in the past, and the supply for these larger spindles is taking a similar amount of power to quite a large heated bed, so don't mess with it. Get a good one. T-nuts, these are sort of spring loaded with a little bore. They're the BOM ones. I highly recommend you do get these for most of your build. Now, the one exception to that is you may want some standard T-nuts, you know, the ones that drop in and then twist as you tighten them, for adding mounts, brackets, things that you add after the build. The reason for that is they're just easy to use, they're cheap, adding things on, but for your main build, these will make your life a lot easier, because if you've got to align 20 of those, especially with the FMJ mod, you need to be wary. I do have a lot more than standard here, and that is because the FMJ has about 1 billion bolts on it. It probably doesn't need that many, but it is what it is. Yeah, just your extrusion corners, nothing special there. They were also from Ooze Nest, and they normally come in the supplier kits for the frames. Right, last few things. So, just some cable chain. It's just the cheap stuff, but it does. I specifically got the one that you can sort of flick open with a screwdriver without having to thread the wires all the way down. And this means if you're adding an extra wire in after you've built it later on, it's just going to be exponentially easier. You will be cursing yourself if you buy the stuff that means that you have to thread it in from the end, because the cost difference is so little. Just get the slightly more expensive one. Otherwise you'll hate yourself when it comes to maintaining things. Right. Now, last but not least, big package from LDO. So thank you to LDO. As usual, they are fantastic in their support of these open source projects, whether it's Voron or the Millennium Mill. They've helped Jake out directly quite a lot, and their contribution to my build here is to provide me with not 3 but 5 chunky motors. So I've got some spares. These are actually rated to quite a bit higher torque than the stock ones, but they do add a fair bit of length to your build, so just bear that in mind if you're trying to use one of the enclosure designs that are starting to be worked on. I have got 5 here. I've only got 4 high current drivers, so it does look like I'll be looking at a 4th axis plus a spare. No idea when that will happen, but at least 3 of them will be going into the main build, and then the others will be useful for the future. Some serious packaging for these bad boys. Big box for just the 5 motors, but they arrive lovely and safe, obviously. And that's it, to be honest, guys. So, those of you who have been paying attention will notice that I do not appear to have any wires or 3D printed parts. So Jake is going to be sorting me on the 3D printed parts, and they'll be arriving soon. The wiring, I happen to do quite a lot of wiring at work, so they will be kindly donating some wiring from their sort of scrap bin, which is meters and meters of useful wires, and that will be the plan for the electronics. I also have a large collection of 3D printer related spares to fill all the other gaps for things like the fans and various other little bits and bobs. But I think that's it. Right, so before I call it a day on the plan, has anyone got any questions about the build, about what I plan to do, or anything we've covered today, any of the kits? Just to cover again, the CNA kit, you have the option of just the rail kit or the complete motion kit, which includes everything. The FISEC kit is a full BOM for all the fasteners, and that includes the spring nuts and I believe the insert and the heated inserts as well. Yeah. Anyway, thank you all for joining me today. Looking forward to starting the build and taking you along the process with me. So, right, have a nice